Good morning, Hamilton County 4th graders. It is Thursday, day 4 of week 5. We are getting so close to the end. I'm so excited. I am ready to just actually start summer as opposed to, it feels like summer, but it's not summer. Here you go. Hey guys, it's been a while since you've seen me. Oh no, I'm moving things that aren't supposed to be moved. Go back. I just wanted to move me, so I'm out of the way. Okay, so the last 3 days we've been working with angles. We've been understanding what they look like, how to measure them, just the different parts of angle. Tongue-tied this morning. Just the different parts of the angles, how we label them. So today, what we're going to do is we're going to take what we know about those angles and we're going to learn how to decompose them and how to add angles and how to subtract angles and why we need to know this, which a lot of the times FSA questions will have an unknown angle that you need to find, and so that's when you're going to really use those benchmark angles and your math sense on how to decompose those angles and find the unknown part. I know a lot of that sounds like German right now, but by the end of our lesson today, you will be angle measuring pros. So, to start, we're going to kind of talk about it first, and I'm going to show you some examples, and then we're going to go into the instructional book, then the practice, and then of course our countdown. Our schedule has not changed much at all. So, I didn't even need to get this pen out just yet. What we're going to do is we're going to go back to our free math app site. Remember, all you got to do is go to the mathlearningcenter.org, and you should be able to get to it very easily, or you can just Google free math apps and find the Learning Center, and it'll take you directly here. And we're going to go into the pattern and shapes, and we're going to open it with our web app, and that should get you right here. Now, to start, I wanted to show a 90-degree angle. And I'm just going to trace it out real quick. You know Miss Hotchkiss is not that great at tracing. So keep that in mind. But I'm just going to try and follow this line down as straight as I can. I don't know why I can't do that. I even switched to an actual mouse. Anyhow, here we go. Alright, and we're going to name this angle. This angle is going to be A, B, C. So we know that angle A, B, C equals 90 degrees. Now what we're going to do though is we're going to change colors, and we're going to decompose this angle into smaller angles. So at the beginning of the week, we talked about how angles turn 1 degree through a circle. So if I have a 90-degree angle, that angle has 91 degree turns in it. This is kind of the same idea of, decomposing. So what I'm going to do is I'm just going to, I want to take off that. Alright, we're going to split this angle up, and we're going to start really easy. Right now we're just going to split this angle in half. So now we have technically 3 angles showing. This is going to be angle DBC. So angle DBC, and it equals 45 degrees. And the other angle that we ended up making was, let's turn that off real quick. We got to turn, so we know that that's a 45 degree angle, but we also made this angle right here, which we're just going to kind of overlap because we do have some overlapping lines. And this angle is going to be angle ABD. Remember, when we're labeling our angles, we start at the top ray, we go down to the vertex, so this would be the first, second, and then third letter of our angle. And as you can see, this is 45 degrees as well. So what we did was we took our 90-degree angle and we decomposed it into two smaller angles. Now, if we wanted to get back to our 90-degree angle, we would just add, let me change my color because we're going back to our original. I would just add 45 and 45, and I would go get my 90-degree angle. All this is showing us is that when we have a 90-degree angle, we can decompose that angle into smaller angles, and all we did was we split it exactly in half and we made two 45-degree angles. Now, why we need to know how to do this. Let's erase all this mess. Let's go back to our 90. Well, let's make it a little bit harder. Let's make an angle that is 135 degrees. So we're going to start with, here we go. This is going to be angle A, B, and D. Now, if we were to decompose this angle, let's say that they said that they had a, we'll call it 60, just because I like 60. So let's say they gave us this angle. So we had angle A, B, D, which equaled, what did it equal? 135, it looks like. 135 degrees. And then we made angle CBD, which was 60 degrees. But the measurement that they did not give us was the A, B, kind of went skewy over there. We want to know what angle A, B, C equals. And how we would do that is we would take our big angle of 135 degrees. So our big angle at 135 degrees, and we would subtract the angle that we know. We know that angle CBD is 60 degrees. And all we need to do in order to find out this unknown angle is subtract what we already have. So 5 minus 0 is 5, we borrow, and that becomes 7. So this should be a 75 degree angle. We can check. Let's turn our protractor so our 0 is lined up properly. 75 degrees. Awesome sauce. I love it when, that's one thing that I do love about math. It's very clean cut. When you have your answer, you have your answer. Alright, let's look at another one. Erase. Yes. We're going to turn our protractor back to where it looks normal. Here we go. Now, let's say, let's put a shape in here. Let's put him in here. Alright, so the angle that we're going to measure is going to be right here. Oops. There it goes. And I don't want red because our shape is red. So we're going to have, here we go. This is going to be our first angle. Okay. And we're going to name it A, B, C. Angle A, B, C equals 60 degrees. If we decompose this angle into smaller angles, like let's say it showed us an angle here. Now we have angle DBC, and it equals 40 degrees. But they want us to find out what this angle is. So angle ABD. Angle ABD is our unknown. Sorry, that looks skewy. Like I said, I'm still learning. So this is going to be our unknown angle. We know that all of our angles combined is going to be 60 degrees. So if we were to write an equation, we would write that 40 degrees plus our unknown should equal 60 degrees. And we all know that when we have an unknown, we need to get that unknown by itself by using the inverse operation, meaning we are going to subtract 40 from both sides. That cancels that out. We subtract 40 over here, and our unknown turns into 20 degrees. And we can check it with our protractor by going here and bringing it down. 20 degrees. Okay. I just wanted to show you guys that real quick because the way they introduced this lesson, I don't quite agree with it, but we're going to work through it. You know, some people learn differently, so even if this might not make a lot of sense to me when I first look at it, you might have a better understanding of it. So, lesson 30. It looks like Flora cuts a rectangular sheet of paper into two pieces on the dotted line. They want to know what is the sum of angle A and angle B. So we're looking at these angles, and we started with a 90-degree angle. Now when we look down here, the questions that they're asking us, they're not asking us to add or subtract or use a protractor. All they're really asking us is to really observe what these angles look like and how we can describe them. So if you look at A, angle A, I'll turn a little bit, that way you're not staring at a wall. Angle A is what kind of angle? It's an acute angle. It's going to be less than 90 degrees. I might need to change my pen. That is really light. I don't like how light that is. That's not it. Oh. Let's see. Let's do purple today. Angle B is also less than 90 degrees. It says, describe where the 90-degree angle starts and stops as it turns through the bottom left corner of the uncut sheet. So we're going to start from the bottom. Describe where the 90-degree angle starts and stops. So it starts at the bottom edge, of the paper here and moves returns, I want to make sure I get that vocabulary right, and turns to the left. So all that's saying is this angle took 91-degree turns starting from the bottom of the paper all the way to the left side of the paper. Then it says, describe where angle A starts and stops as it turns through the bottom left corner of the cut sheet of paper. So looking at angle A, it's going to start at the bottom. It turns from the bottom of the paper to the dotted line. So to the dotted line. And then if we look at angle B, B starts at the dotted line and turns to the left of the paper. Then E says, compare where the turning starts and stops for the 90-degree angle with turning through angle A and going on through angle B. So if you turn through A and then through B, you start at the same place as the 90-degree angle does. So if I wanted to, we knew that the 90-degree angle started at the bottom, went through that dotted line, all the way to the left side of the paper. If we look at angles A and B, and if we were going to follow through that 90-degree turn that was over here, it would be the same path. They are the same path as the 90-degree angle. So just how we were going, let's go back over here. Get our protractor out. Just how we were talking about our 90-degree angle here, and if we were to split that up, I gotta move me again. Oh my goodness. Okay. And we were to split our paper, this would be angle A, then this would be angle B, and then we would have our 90-degree. You see how they follow the same turns. That's very important. Alright. To the back of the page. When Flora cut the sheet of paper, she split up a 90-degree angle into two smaller angles. We could decompose or split up any angle into smaller angles, unless it's like a 1-degree angle. Like, you're not really going to get any smaller than that. Remember that an angle's measure is the number of 1-degree turns it shows. You can think of any angles as a group of 1-degree angles with a common vertex. So all that saying is what I had said before. If I have a 90-degree angle, that angle has 91-degree turns in it. So we have a picture of a 10-degree angle with 10 1-degree angles in it. We can decompose a 10-degree angle in a few different ways. So like if we had a 4-degree angle plus a 6-degree angle, that would make a 10-degree angle. Or a 7-degree angle and a 3-degree angle, that would make 10-degree angles as well. So on the reflection, it says, is it possible to decompose a 100-degree angle into two 60-degree angles? So let's look at a model of that. So if we had a 100-degree angle, let's clear all this out. Bring back the protractor, bring back my little drawing tools. So we had a 100-degree angle. Whoop, there it is. Let's color it in real quick. Oh, and it's going to be squiggly. Oh. I really hate drawing with a mouse. Oh my gosh. Oh god, and that was horrible. Miss Hotchkiss, why are your videos so long? Because it takes me an hour to draw a straight line. Okay, there we go. We have a 100-degree angle. Now, the question says, can we split this angle up into two 60-degree angles? Well, 60 degrees would be right here. So that would be one 60-degree angle. Let's go ahead and draw that out. Here we go. And this is going to be our 60-degree angle. And then we're going to measure the angle that we just made. So this angle right here should be 60 degrees if we can do it. What we're doing right now is we're finding out if we can do that. So we're going to move our protractor so our bottom line in our angle measures up at the 0. Well, that didn't make a 40-degree or a 60-degree angle, did it? It's not possible, because if we had two angles that were 60 degrees each, 60 plus 60, 60 plus 60 would equal 120, not 100 degrees. So, no, let me go back so you can see what I'm writing. So no, because 60 plus 60 equals 120, which is not equal to 100 at all. Alright, moving on into the practice pages. Scooch. Okay. Charlie, in the example, Charlie is designing a roof for a new building. He draws the angles below to show two roof designs. What is the measure of the angles at the top of each roof in the drawing? Use a protractor to measure each angle. Wow, they really make an assumption that we have protractors on hand, don't they? So, what we're going to do, we're going to use our benchmark angles. And I'm going to use this to kind of guide me. Alright, so if we were, let's turn it this way, that way it's easier. If I said this was my 180 degree line, here is my 90 degrees. I always like to do this in different colors though. Let's see, we got a light green in here. This angle is less than 90 degrees. And so if I were to split 90 degrees up in half, it would be 45 degrees. So if I just assume, like here's my vertex, this would be about the middle. So it's a little less than 45 degrees. I'm going to call it 42 degrees. Let's measure this one. So here are our benchmark angles. This could be, that's our 180. And then let's use a different color. Here's our 90-degree angle. This is definitely going to be less than 90 degrees. Our halfway point falls, let's see, 45 degrees would fall about here. So it's a little more than 45 degrees. I'm going to call that at least probably 70 degrees. See how I'm using those benchmark angles? I'm telling you guys, they're a lifesaver. All right. Number 1, draw a roof design that has an angle measure between 42 degrees and 68 degrees. So to do this, we're going to draw our 180 degree angle. This is our 180. We're going to draw our 90 degree angle. And we want an angle that is between 42 degrees and 68 degrees, meaning it's going to be less than 90 degrees. And the easiest way we could do this is we're just going to split it down the middle, because half of 90 is 45. So here we go, right here. And we're going to say that it is 45 degrees. Can you guys see that okay? Zoom in as best I can. Alright. Now it's saying draw a roof design that has an obtuse angle. So here's our 180. That's our 180 degree angle. Here is our 90 degree angle. And obtuse means it's going to be more than 90 degrees. And a good estimation of that would be, you could say, over here would probably be about 100 degrees. Yeah, just about. So 100 degrees. And you can make it bigger, and you can, make a different estimate than mine. That's fine. We're just estimating. As long as it is apparent that you did draw an obtuse angle, it is apparent that you drew your benchmark angles, you should be around the same ballpark as what you should be in. Okay. Number 3. Whoa. Just pause for 1 second. I do have to answer this email. Anyhow, so Madison drew 3 rays and realized she had drawn an acute and an obtuse angle. Label the angles acute and obtuse. Use a protractor to measure each angle and write the angle measure. So this is our 180 degrees. Here is our 90 degree angle. They want us to find angle, we'll call it A, B, C, and angle C, B, D. So, angle ABC is acute. It's smaller than our 90 degrees. And I would be okay with saying anything between 45 degrees to 55 degrees is where that angle will most likely fall. Then if we look at angle CBD, this angle right here, it's going to be our obtuse angle. because that angle is much bigger than our 90-degree marker, is obtuse. And if this is 90 degrees, I can probably say that this is going to be anywhere between 130 degrees and 120 degrees. Okay. Now we're going to draw an angle of 152 degrees. Draw that benchmark angle of 180 degrees. Don't forget your degrees. Here's our 90-degree mark. Our angle is going to be obtuse because it's more than 90 degrees. So it's probably safe to say that would probably be 160. So we're going to go about to here. This angle would be our about 152 degrees. Alright, now number 5 says measure each angle in the quadrilateral below. Write each angle measure. So we're going to need a couple different colors. So let's look at angle A for a second. Angle A is acute. So if we had a 90-degree angle here, that's almost exactly half of that. So if you said anywhere between 45 to 50 degrees would be fine. Angle B almost looks like it's congruent, doesn't it? There's our 90-degree turn. So you could probably say that this too might be a little bit wider. Let's see. Yeah, it might be a little bit wider. So anywhere from 50 degrees to probably 60 degrees would be right. And then let's look at the angle formed at the vertex D. This is going to be an obtuse angle. If we drew our 90-degree marker, we could see that it is a little bit more than 90 degrees. So probably anywhere from 110 to 130 degrees. It's a little bit harder to see that one. I will give you that. And then our last angle at vertex C. There's our 90-degree mark. This obviously goes over that. It is obtuse. But it doesn't go over it by much. It's going to be smaller than our first one. So this could probably be anywhere from 100 degrees to 120 degrees. You guys are going to be pros at estimating angles since we're having to do all of this without without our protractors. Alright, last bit for the day. Day 15 countdown. Oh, I need to zoom out. Zoom out, zoom out. Okay. Paris is arranging the chairs for a recital. She wants to put the 36 chairs into a rectangular array. Complete the table to show 5 ways that Paris can arrange the chairs. So, all we're doing is figuring out, I could have 36 rows with 1 chair in each row, because that doesn't go over my 36. Thinking about factors of 36, I could have 4 rows with would be 4 times 9, 4 rows with 9 chairs in each one. We could say 6 chairs, or 6 rows with 6 chairs in each. We could do 12 rows with 3 chairs in each. Or we could do 2 rows with 18 chairs in each. Those are just the factor pairs for 36. If you notice, 4 times 9 equals 36. 6 times 6 equals 36. 1 times 36 equals 36. 12 times 3 equals 36, and 2 times 18 equals 36. Hopefully you guys are working on your multiplication tables, because I'll tell you what, once you have those multiplication tables memorized, a lot of these questions will start making a lot more sense. Alright, look at the numbers below. Write each number under prime or composite. Remember, a prime number only has one factor pair, which would be 1 in itself. A composite number has more than one factor pair, 1 in itself and then other ones. So let's pick out our prime numbers first. So we know that 2 is the only even prime number in existence. 63, well, we know that 7 times 9 is 63, so it's not going to be 63. 67, there are no other factor pairs for 67, so that makes it prime. And then we have, gotta think, yep, 83. 83 is prime as well, because the only way we can get 83 is by multiplying 83 times 1. And then we're left with our composites. We have 63, 1 times 63, and then 9 times 7. And then we have 91, which I believe is 13. 13 times, can't remember, 13 times 3. No. Hang on. Gotta think. I believe it's 3. 3 goes, we can always check with division. 3 goes into 9 3 times. That's 9, 0, 1. No, it's not 3. Trying to think. It wouldn't be 5. It wouldn't be 2. Does 7 go into it? 7 divided by 91. 7 goes into 9 once. That's 7. 7 times 13. There it goes. So 91 is composite as well. Alright, number 3. What factors do 28 and 40 have in common? Mark all that apply. Well, we have definitely 1, because all numbers have 1 as a factor. 4 times 7 is 28, and 4 times 10 is 40, so they have that in common. It's not going to be 5, because in order to be a multiple of 5, you either have to end in 0 or 5, and 28 does not end in 5. 8 does not go into 28, and 14 does not go into 40. So it's just A and E. Number 4. Connie wrote a number pattern with the rule add 12. What do they want us to do? What statement is true, I suppose? So every number in the pattern is odd because the initial number is odd and the rate of change is odd. So when we add 12, yeah. Okay, that could be true. Every number in the pattern is even. We already know that's not true because they're not even. Every other number in the pattern is even. Again, they're not even. There is a pattern of odd. Well, that was easy. That looked really complicated for a second. Alright, so use the rule to write the first 5 terms of the pattern. So our rule is add 6 and subtract 3. Our first number is 7. So we're going to add 6 to 7 and then subtract 3. So 7, 8, 9, 10, 11, 12, 13. And then we're going to take 3 away, which would be 10. And then if we do that again, we would have 10, 16, subtract 3 would be 13. 13 plus 6 would be 19. Take 3 away, that'd be 16. And then 16 plus 6 would be 22. Subtract 3 would be 19. Awesome sauce. Whew, that did go a little over though. I'm sorry guys. I hate when the videos hit that 40-minute marker. For one, it takes forever to upload. Anyhow, we will get this going. I'm not sure if I'm going to try and upload this morning because we do have a Zoom meeting, and whenever I'm doing video uploads, it always messes up on me because the internet and everything. I just wanted y'all to see my face. But it will, as soon as that Zoom call is done, I will upload this and get it going, and boom. Day 4 is done. We're on track for the most part. I do have most of y'all's DBAs done. If you have not heard from me, I will be calling you this afternoon. Boom, boom. Either this afternoon or tomorrow afternoon. I need to get the participation grades in before Friday night. So you need to get it, if you have not sent me pictures yet, you have until 4 p.m. on Friday to get me the pictures of what you have done in order for me to come up with a participation grade for you for progress reports. If you've already done this, great. If not, we really need to get on the ball. I know some of you are a little behind in the packets. We need to be watching these videos. We need to be getting caught up. And this doesn't have to do with, oh, so I can get grades. This has to do with, this is stuff you need to know for 5th grade. You will be most likely going into 5th grade unless I've already talked to you and we're not sure. But I really don't have anybody. Pretty much all of my kids that I know of are going into 5th grade next year. So if you're skimming through this work, if you are not paying attention to what you are doing, you are going to put yourself in a deficit in 5th grade. That is why I chose to do these videos, to ensure that you understood what you were doing and that you had the support that you would have had in the classroom. So, I'm not doing this for my own health, okay? It took a lot for me to figure out how to do these videos. Those of you that started watching early on, you know the drama. Kylie, you know what I had to do. But we're going to get through it. We're going to get you caught up. If you're behind, we're going to get you caught up. We need to get things rolling. If you have not sent me pictures, which the vast majority of you have not sent in pictures, and so you need to get those pictures sent in to me before the end of day on Friday. Ooh, I feel like I'm going to sneeze. Either way, I will see you guys in the Zoom call. Hopefully, starts at 11? Yeah, at 11. Alright, bye guys. Have a great day. I'll see you later.